Hello everyone and welcome to my presentation. My name is Sara SAEIDI and today I would like to present some results of my PhD research at the University of Regensburg on a DFG ANR funded project of Paleo Persepolis. In this presentation I will talk about historical vegetation changes of the Persepolis Basin in southwest Iran within the man-climate ecosystem nexus during the Holocene. I will begin with some introduction about the study area, then I will move to the result of the study. Persepolis Basin is located in the southeastern edge of Fertile Crescent and southwest of Iran. At the southeastern section of Zagros Mountains, the Persepolis Basin has experienced the presence of human settlements for millennia. This basin is basically the elevated intermountain plain of Mardasht plus two nearby sub-basins in the north and the northwest. This basin witnessed the emergence of several great civilizations like Elamite, Achaemenids, and Sasanian, and it was the political and social center for Sasanian and Achaemenids. Such civilization, of course, had major impacts on the environment because of their social structure and different strategies in using the resources. I should mention that the archaeology and history of this area is well studied, but knowledge about its vegetation history is limited. Persepolis Basin has very particular bioclimate and biogeographical setting. It is located between dry Mediterranean bioclimates in the west and tropical desertic one in the east. Biogeographically, it is located in the boundaries of the Irano-Turonian and Sahara-Sindhian regions. The Irano-Turonian vegetation mainly comprises of scattered pistachio and almond steppe scrubs, mainly Pistachia Khinjuk, Pistachia atlantica, and Pronus scoparia, while Ziziphus prosopis acacia type is the main Sahara-Sindhian vegetation type. The pistachio almond scrub, of course, gradually combines with the Quercus brandtii or Zagros oak at higher altitudes, around 1,000 to 2,000 meters. Although, because of the long-term history of anthropogenic activities, this vegetation has been substituted with the cushion-shaped Tragacanthic species at higher altitude and Artemisia steppe in the lowlands. So much for introduction. Let's move on to the study and the result. Today I present the historical vegetation and burning events of the last around 4,000 years inferred from palynology and macroscopic charcoal analysis on a sediment core from hypersaline lake of Maharlu in the southern part of the basin, as you can see in the map. Then I will add older evidence of vegetation for around 10,000 to 6,000 BP inferred from an anthropological study on the archaeological remain from Tape Rahmatabad. The palynological study showed the periods of changes in natural vegetation as well as urban development and agricultural activities. Tree cultivation and orchard development also reflected in the results. Here we showed that the plane tree, pomegranate, wine tree, olive, walnut, and date palm were the main cultivated trees in the southern part of the Persepolis Basin. Here you can see the summarized pollen diagram on the top. And for the detailed result of this pollen analysis, you can have a look on our last publication in Vegetation History and Archaeobotany Journal. So, despite several paleoecological studies in the interior part of Iranian plateau, so far no fire history investigation have been done in this area. Here I present the result of the first attempt, and for that I used both charcoal number and charcoal area records to decompose the charcoal peaks. The screen charcoal peaks showed regional and local biomass burning, and I should mention that the main woody vegetation type of the area comprises of the broadleaf species, which are less sensitive to natural ignition compared to the coniferous forest. Therefore, natural fires are expected to happen with very low frequencies. But with the long history of human presence and activities in this basin, burning practices were very likely used by people. So let's now have a look on all proxies together. And as you can see in the right hand side, historical periods are shown in the bottom. Fire history come afterward, and then Paleo Hydrology of the lake, and the summarized pollen data in ecological groups and pollen ratios on the top. I should mention that the reconstructed Paleo Hydrology of the lake has been done by Dr. Elodie Brisset and her colleagues in 2019. And in this study, they documented three main hydrological conditions in the Lake Maharlu. First, period of wet conditions with higher river-borne sediment input in the beginning of the record during the 3,800 to 2,000 BP. And then a hypersaline conditions with drier climate from about 2000 BP to present time. And from 1100 to 700 BP, they showed nearly complete desiccation of the lake that happened frequently during this time. So at the beginning of the record and during the zone A, pollen records show a period of increase in grassland or grass steppe coverage, while the natural forest vegetation had relatively steady status. The pollen ratios show higher moisture availability, which agree with the geochemical evidence for a period of frequent flood events in the basin. These results are consistent with the moisture increase in the Southwest Asia during the mid to late Elamite period. Of course, this grass steppe provide more fodder for livestock, and here we see the first peak of Sporumiella appears in this period, and it can support this idea. In the same zone, the oldest macrocharcoal peak is recorded around 3,600 BP. The background charcoal and microcharcoal records also show high values during this time. Considering the high fluvial activity, also no strong evidence for vegetation reversal, this peak is likely a result for catchment redistribution related to erosion rather than fire dynamics. And historically, this period corresponds to the mid to late Elamite dynasties. So growth in grass-type pollen and coprophilous fungi spores can show indirectly the population growth and development of the first urban centers, as it is shown by archaeological studies in this region. As I mentioned before, after 2000 BP, the basin experienced several periods of dry and wet climate conditions with an overall drier climate. In the middle part of the pollen diagram, so in the zone B, natural forest started to decrease slightly from 2800 to 1700 BP. This event is centered around the cool and wet climate of 2.6 event. Theoretically, the regional ecological conditions should have been in favor of preserving or even expanding the natural vegetation, but forest and grass pollen type decreased to almost half of their values during this period. Also, we see here a constant presence of Sporumiella and disturbance indicator pollen type like Tribolus and Prosopis farcta. I should add that these taxa represent disturbed and overgrazed habitats in semi-arid areas in Iranian plateau. Altogether, these results suggest intensified pastoral activities and overgrazing during this period. Also, we can see it from the continuous curve of cereal type pollen and cultivated trees that agriculture seemed to play important role in the vegetation dynamic of the basin during this time. And at the end, historically, this period corresponds to the Imperial Persia, including Achaemenid period. The Achaemenids started to build their superpower centered in Persepolis and other intermountain basins of Fars. The rise of such geopolitical power, of course, required using the natural resources intensively. Therefore, the decline in natural vegetation pollen values may reflect deforestation activity and overgrazing during these empires. Adding to that, the fire history study suggests an episode of local biomass burning in around 2300 BP, with, of course, a low magnitude. As we can see, the background and macro charcoal represent their lowest values here, which suggests a local scale for this episode. Based on the history and the archaeology record, this charcoal peak occurred and correspond to most prosperous stage of Achaemenid Empire, a few decades before their end by Alexander invasion. So we suggest that probably this charcoal peak is related to many low magnitude fire that happened scattered across the watershed, so by people to use the resources. The last pollen zone corresponds to around 1600 BP to present time. As it can be seen in the graph, the Zagros forest started to recover by around 1600 BP, but the growth was mainly related to oak woodland, while pistachio almond scrub decreases in the meantime. Similar difference between oak and pistachio vegetation type was explained before by Miller for the Tapromalion in the center of the Persepolis Basin. She suggested that the lower altitude pistachio almond vegetation was destroyed more because of growing number and area of the settlements. As I mentioned, from 1100 to 700 BP, Mahor Lake went through many desiccation events. And after 700, the frequency of these events decreased, most likely because of relatively wetter climate of the Little Ice Age. This event is documented as decrease in agriculture as well as forest cover in several pollen records from Iran, like Lake Almalu in the northwest. We see here also the same trend in Lake Maharlu. Adding to that, we can see the sign of increasing anthropogenic pressure on the landscape, which is related to the high values of ruderal and disturbance indicator. And historically, in this period, Fars province and Maharlu Basin witnessed a massive landscape destruction by Mongols, plague outbreak, and many phases of political instability. These circumstances probably forced people to change their lifestyle and adopted pastoral nomadic mode of life to guarantee their survival. Such nomad communities caused the increasing pressure on forest or shrub ecosystem. Adding to that, fire history study showed two charcoal peaks in the period that the first possible burning episode is around 600 BP. Despite of high magnitude, this peak is concurrent with the high values of background and particularly micro charcoal, as well as higher sediment accumulation rate. Therefore, the peak is most likely related to increase in sedimentation rate rather than the burning. Our study also showed increasing aridity and expanding halophytic vegetation belt around the lake in the most recent 200 years. And according to World Bank and FAO report, the amount of the burned forest and rangeland areas in Iran grew significantly in recent decades. Here, the most recent charcoal peak with a relatively high magnitude is probably related to the regional fire, because the macro charcoal and background charcoal records are also increasing together with this peak. Although no burning episode is reported for Maharu Lake Basin, but a vast fire in the southern rangelands of Fars province was reported by the national agencies. At this point, I'd like to add briefly some older information from Rahmatabad side. As you can see, the chart shows the percentages of different taxa in Rahmatabad charcoal assemblage. We show that The relatively high value of pistachio charcoal is consistent with the period of expansion in pistachio-dominated vegetation in the Southwest Asia. Also, we suggest that the oak-dominated woodland were infrequent around the site because of finding the oak acorn remains, while we couldn't find any oak charcoal in the assemblage. I should mention that compared to the other part of the Zagros Antitaurus Mountains range, oak-dominated woodlands expansion delayed in the Zagros Mountain because of climatic factor. Another interesting point was presence of Myrtus communis, a relict Mediterranean species in charcoal assemblage since 6 millennia BC. This period coincides with the 8.2 cooling event in the northern hemisphere. It has been argued that compared to other parts of the Southwest Asia, the drier climate of Iran changed after 6,300 BP, with a gradual increase in humidity and precipitation. Therefore, we suggest that this 8.2 event probably didn't have severe impacts on the local climate and Rahmatabad's surrounding landscape, so it provided a suitable macroclimate for cold-sensitive taxa like myrtle. And to summarize, in this study, we tried to present an update reconstruction for the vegetation of the study area. The results showed the role of anthropogenic activity and hydroclimatic changes in modifying the landscape. A study on Rahmatabad site support presence of oak woodland and pistachio almond vegetation types since 8,000 BC. With less oak cover at the beginning, of course. We also suggest that during the cold 8.2 climatic event, the milder climate of the study area provided refugia for cold-sensitive taxa. Several periods of change in the natural vegetation of the basin can be inferred from the presented result. In general, the oak woodland in the basin experienced relatively a stable situation until around 2800 BP, while grassland expanded. Both are correlated with the period of wetter climate. And after that, the drying climate, along with increasing anthropogenic activities, forced the woodlands to decline. Scattered, frequent, and low-magnitude fires during this period are related to human activities. Pollen analyses also showed that pastoral activities, agriculture, and tree cultivation played important role in defining the vegetation dynamic of the basin. And finally, the most recent 200 years, the study area experienced increasing aridity and chances for vast regional fire. Thank you very much for your attention, and if you have any question, I will be happy to answer.